morning, students. In the previous video of gravitation, I told that Kepler's three laws and Newton derived his universal gravitational law from these three laws. So now this is another video on gravitation, and this is part 2. Here we will discuss about Newton's law of gravitation, that is Newton's famous universal law of gravitation. Now in the previous video I told that from the three laws of Kepler, Newton proposed on his universal law of gravitation. And what were the three laws? Those were law of orbits, law of areas, and law of period. So in the year 1687 Newton proposed this famous law, and this is the statement that I have written. What does it say? Everybody in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Now according to this diagram, we can say that this is an object of mass m1, and this is another object of mass m2, and the distance between them is r. So according to the law which says that the force which is directly proportional to the product of their masses, so if we consider this, then we can write that F is proportional to m1 and m2. And this also says that the force is inversely proportional to the square of the distance between the two objects. Then we can say that F will be inversely proportional to 1 by r square. Inversely proportional to r square, that is F proportional to 1 by r square. So combining these two, we can say that F is proportional to m1 m2 by r square. And when we write it like this, when we bring an equation, then we have to write F equals to g into m1 m2 by r square. Now what is this g? This is the proportional constant, and this is called the universal gravitational constant, or simply the gravitational constant. And this is Newton's law of gravitation, the mathematical expression of Newton's gravitation law. Now from this mathematical expression of Newton's law, that F equals to g into m1 m2 by r square, if we consider that the mass is of unit mass, m1 equals to m2 equals to 1, then from this law, from this equation, we can say that F equals to g by r square. Now again, if we consider that the distance between them is unit, then we will consider that r equals to 1, m1 equals to m2 equals to 1, because the objects are of unit mass and the distance between them is also unit. So r will be equal to 1. Then we can write F equals to g. So from this equation we can define g like g is the force, because here we can see that F equals to g, the force is now equals to g. So we can define g like the force by which unit masses situated apart by unit distance attracts each other is called the gravitational constant. That is, when the masses are unit masses and their distance is also unit, then the attracting force between m1 and m2 will be equals to g. And what is the unit of g? G is unit equals to F, unit of F into unit of r, I mean square of the unit of r by m's unit, the square of m's unit. So what it will be g's unit, and how do we get this? Because we know that f equals to g, well, we can write like if f equals to g into m1 m2 by r square, so we can say that g equals to f into r square by m1 m2. Now as both are mass, so we can consider it, when we are considering the unit, then we can consider it as m square. So from here we can say that g's unit is f's unit, r's unit, and by m's unit, that is mass. So in CJ system, the value is value now. So in CJ system the unit is dyne centimeter square per kg square, and in SI unit the unit is Newton meter square by kg square. And the dimension of G, what is the dimension of G? Same as a unit, f dimension of f, dimension of r, and dimension of m. Okay. Now what is the dimension of G? G's dimension is dimension of f into dimension of r and the square, and square of dimension of m. Now f is the force, so its dimension will be m l t to the power minus 2. The dimension of r is l, and due to the square it will be l square by dimension of m, that is m square. Now solving this, we get that the dimension of G is, this is square and this is 1, so it will be m inverse. There is no t in the denominator, so it will be t to the power minus 2, and l into l square, that is l cube. So this is the dimension of G. Now arranging this, we get that the dimension of G is m inverse l cube t to the power minus 2. Now we will discuss about the values or magnitude of this G in CGS and SI system. So now we can see that the value of G is, in CGS system it is 6.67 into 10 to the power minus 8 dyne centimeter square gram to the power by gram square, and in SI system it is 6.67 into 10 to the power minus 11 Newton meter square per kg square. So be careful about this unit, and we can see that minus 8, it is of minus 8 order, and this order is of minus 11. Now we will discuss on gravity of earth. Now what is the gravity of earth? We all know that earth is pulling everything towards its center, and if we consider the earth as an uniform sphere, then the mass of the earth m will be concentrated at the center of earth. Now suppose an object of mass m is at a distance small r from the center of the earth, then earth will attract this object towards its center, and this is a force which is we denoted by capital F, and this effect is the gravity of earth. Actually, gravity is the pulling force of the earth towards its center, and due to this force, the object in this object an acceleration is generated, and which is called acceleration due to gravity. And we all know that according to the gravitational law, F equals to this force equals to G m by r square, and this r is the radius of the earth. Now, due to this force and according to Newton's second law, the acceleration due to gravitation is generated in this object of mass m. Now, this acceleration due to gravity will be denoted as small g. This is acceleration due to gravity. And the SI unit of this g is for earth 9.8 meter per second square. This is meter per second square is the unit of acceleration in SI system, and the value of g slightly varies from place to place, but for solving numerical problems, we will consider this 9.8 meter per second, this value. Now we will discuss about the relation between capital G and small g. As we know that F equals to Gmm by r square, this is the gravitational constant, and small g is the acceleration due to gravity. And from Newton's second law, we can say that F equals to mg, m equals to mass and g is acceleration. So force equals to mass into acceleration. Now we can from these two equations we can equate that mg equals to gmm by r square, as I have written here, mg equals to gmm by r square. So if we cancel out small m, then we will get that small g equals to gm by r square. Now we know that this g is a constant, and m, the mass of the earth is also constant. So this constant terms, if we consider it, then g will be proportional to 1 by r square. So this is the radius. If we consider that r equals to capital R, that is, if anything is on the surface, or this r is the radius of the earth, then from here we will get that g equals to gm by capital R square. So this is the relation between g and capital G. So I am ending this video here, and we will continue the next topics in the next videos. Thank you.